Covalent bonds come in different flavors, if you will. So you can have, so let me make the broad category of covalent bonds, and they can really be separated into two types, either polar covalent bonds or nonpolar covalent bonds. To understand the difference between polar and nonpolar covalent bonds, we have to talk about electronegativity. Electronegativity is a trait of atoms that's the ability of that atom to pull electrons to itself. So it's how strong the atom is and how much it pulls on electrons. So the more electronegative an atom is, so the higher its electronegativity it is, the harder it pulls on electrons. Okay. So when atoms are sharing electrons, you can have a situation where you have a strong atom sharing electrons with a weak atom. So because the strong atom and the weak atom have this difference in the ability to pull electrons, they're sharing a pair of electrons. So those are my electrons. But instead of the electrons being perfectly evenly shared, right? So maybe like if I have two atoms that are both weak, then the electrons would be exactly in the middle of the two atoms. But when I have a strong atom and a weak atom, the strong atom pulls the electrons slightly closer to itself. So they're still sharing, it's not taking them away, but it's not sharing them equally. This will create a polar covalent bond. This is significant because if this atom has more electrons near it, then it gets what's called a partial negative charge, and this is just a little symbol that we use for partial. So it has essentially a little bit extra electron, so that's why it's a partial charge. And this one is missing a little bit of those electrons, so it ends up with a partial positive charge. So that's where the term polar comes from, like the pole, you know, the north and south pole. Polar means opposites. So you end up with one side of the bond where there's a negative charge and one side of the bond where there's a positive charge. Again, remember, these are partial charges. It's not the same thing as ions that we were talking about earlier because they're just a partial charge. So water is the classic example where we see polar covalent bonds. So oxygen is a very strong atom. It has very high electronegativity. Again, let me get my pen turned on here. So oxygen is strong, and hydrogens are weak. And again, based on electronegativity, so I'm kind of using these judgmental terms here, but that's from their electronegativity. So that means when they're sharing electrons, so these are covalent bonds here. Let me just change my pen color so you can see this a little bit better. So I've got a covalent bond here between oxygens and hydrogens. Again, they're sharing electrons, but they're not sharing them equally. So here's my electron pairs, and they're tending to hang out closer to oxygen than to hydrogen. So because of that, because the oxygen is pulling them towards them slightly, it's creating a partial positive charge region on the hydrogen, partial positive on this hydrogen, and a partial negative on the oxygen. And so this is a polar molecule made of polar covalent bonds. In a nonpolar covalent bond, you have atoms that have similar electronegativity. And so earlier I was drawing this as weak bonded to weak. So for example, hydrogen has relatively low electronegativity bonded to itself, which also has low electronegativity. Then those electrons are going to be shared very evenly. So anytime really you have two atoms of the same, so you could have strong to strong, even though they're both strong, they're still equally pulling on those electrons. So the electrons will still end up in the middle, and this would be nonpolar. There's no partial positive, partial negative. So oxygen to oxygen is nonpolar, carbon to carbon is nonpolar, hydrogen to hydrogen is nonpolar. The one that we're going to see a lot of where you have two different atoms that's still nonpolar is carbon to hydrogen. So this is still a nonpolar bond. Carbon and hydrogen have low electronegativities, and they're about the same. So it's basically a weak to weak one. So you have no partial charges on a carbon to hydrogen bond. So again, just to summarize here, polarity is when electrons are not shared equally because you have differences in electronegativity. So oxygen to hydrogen is a classic polar covalent bond. So is nitrogen to hydrogen. Both oxygen and nitrogen are electron bullies, is kind of how I always say it. They're very strong. They will pull electrons towards themselves. And so kind of the guideline in biology is whenever you see oxygen and nitrogen, you're probably looking at a polar covalent bond unless, like I said earlier, they're bonded to the same thing. So water is not just made of polar covalent bonds, it's also a polar molecule. So polar molecules are molecules that have one or more polar covalent bonds. So over the course of the semester, we'll refer to things as being polar or nonpolar. And again, what we mean by that is that they contain polar bonds. Water is an extremely polar molecule because it has two polar covalent bonds. Some molecules will be less polar because they might be a very long molecule like this, and they might have only one polar covalent bond. And so that would be less polar than water. And so again, I just want to remind you that you have hydrogen to oxygen, and you're getting a partial positive on the hydrogen, partial negative on oxygen, partial positive on hydrogen. So for the water molecule, you can kind of imagine that these are little sticky spots. This partial positive region is going to stick to anything that's partially negative. This partial positive area is going to stick to anything that's partial negative. And this area is sticky for positive. So if you imagine water as a little triangle, you have a sticky part here, a sticky part here, and a sticky part here. And they're going to be sticky in like Velcro kind of way, where you have to have matching parts. So this is positive, so it'll stick to negative. This is negative, it'll stick to positive. So polar molecules are going to be sticky, and they'll stick to each other and other things that are charged.